So before you can answer any questions, you need to make sure you know what are the quantities being measured. So what are the quantities that we're measuring? And in this example, we are measuring weight and we are measuring time, and we know that because of the word months. And we also see that the weight of the alligator is being measured in kilograms. And remember that the independent is what is going to be inside of the parentheses. So if I look at my function notation here, I see that the 7 is inside of the parentheses. So the 7 is my independent. And what is outside of the parentheses is dependent. Time is always going to be your independent. So that means that the 7 represents months because time is your independent. And that means that 15 is going to represent kilograms because that is how the alligator's weight is being measured. So that means it has to be option B, and it has to be option B because it's the option that has 7 months and 15 kilograms. For number 2, again, we need to look at what quantities are being measured, and we're measuring hours and the amount of cupcakes. So we will have our hours as our independent, and the amount of cupcakes will be our dependent variable. So that means in letter I, the 3 represents hours because that is our independent variable. And it doesn't tell us how many cupcakes because there's nothing on the other side. So this is how we would write that. The number of cupcakes to represent that C that's in the front after 3 hours to represent the 3 that is inside of the parentheses. Now, we can't write a complete sentence because we don't know how many cupcakes. So that's why this is not a complete sentence or a complete thought. But the second part does have all 3 parts. So this will represent a full sentence. The first part will be the number of cupcakes, and that's because of the C in the front of the function. The next part, after 0.5 hours, because of the 0.5 inside of the parentheses. And then the rest of our sentence will be, was 14, and I got that from the 14 out here on the outside of my function notation. For part B, letter A, it says to write using function notation. So I'm going to start with the C because that's the name of the function. I'm going to say because it's 6 hours after the bakery opened, that is where the 6 came from. There were 2 cupcakes left, so that is where the 2 comes from. One tricky thing about part B is that the measure is supposed to be in hours, but in this situation, they gave you minutes. So make a note, you're going to need this, that 90 minutes is the same thing as 1.5 hours, and 120 minutes is the same thing as 2 hours. So when I go to write my function notation, it's still a C to represent the number of cupcakes. I'll put 1.5 in parentheses to represent that this was after 1.5 hours. And then it also says was the same as. Well, what do we use in math when we talk about something being the same? We use an equal sign. And it says the number of cupcakes after 2 hours. So this is how you would write the function notation. And again, make sure you use 1.5 and 2. Don't use the 90 minutes and the 120 minutes. So the key point of information we need here is that your x value is the number that is in the parentheses. And letter H is correct. And letter H is correct because if I look over at my graph where x equals 10 and x equals 15, so I'm going to zoom out here. So there's my two places where x equals 10 and 15. And if I travel up to the graph in both places, I see that the graph is at the same location, right here in the same place. So that tells us that W of 10 and W of 15 are equal to each other. J is also correct. If I go on the x-axis to where x is 5 and x is 15, so 5 and 15, and I follow the trail up to the graph in both places, you see that the location on the graph here at f of 5 is lower than the location right up here. So because it's lower, that means it's also less than, which means that J is correct because W of 5 is less than W of 15 because it's lower. K is also correct. So the first part we need to look at is where it says T is 30. So I'm going to go to time, and I'm going to go to where T is 30, and then I'm going to travel up to the graph, which is right here, and you can see that that point on the graph does line up with 100. So that means that W of T, the Y value, is 100 when the T value is 30. Then our last coordinate our last option that is correct is N. And the reason N is correct is because I'm looking at my X value of 30, which is, oops, sorry, I just realized I made a mistake. N is not the one that's correct. It is M, sorry about that, that is correct. And the reason why that one is correct, if I go to 0 on the x-axis and I go up to the graph is right here at 75 on the graph because it is between 50 and 100. So 0 and 75 match up. For part A, I can see if I go over to the 20 on the x-axis and I travel up to option A, you see there's A of 20, and then B of 20, where it hits the B line, is lower. So because the A of 20 is higher than the B of 20, B of 20, oh, sorry, I don't know what is wrong with me. A of 20 is the one that is larger. Is there a place where they are equal to each other? And if I look on the graph and I zoom in here where the two graphs intersect, this is where the two functions are equal. And if I look at what value that is, if I travel down to the graph, it's right here halfway in between 30 and 40, which means it's at 35. So we would say, yes, there is a place where they're equal, and it's where the months equal 35, because it's right here on the axis, halfway in between 30 and 40, where they're equal. Last, it says identify a place where the inequality B is less than A. So where is the B lower on the graph? And because there's already so many colors on here, I've got kind of a fresh option right here, and just wanted to point out to you exactly what's happening with this graph. So option B is this blue line that originally started off lower, but then as it gets more expensive, it eventually gets higher than option A, where option A stays the same the whole way. So option B is cheaper for any value until we get to where they're the same, which we already talked about was 35. So any value for M that is less than 35 will work, because M stands for months. So again, on the graph, I know there's, oops, sorry about that. I know there's a lot going on the graph here, but it'll be any place here until they become equal. Okay, last question, last learning target for learning target number 3. The two that are correct are I, and the reason that I is correct. So remember, the vertical intercept is where the graph hits the vertical line. So this spot right here is the vertical intercept, and it shows the height of the B at the beginning of time. And the reason we know that's the beginning of time is because it's when t equals 0, because that is the beginning. J is also correct because the maximum, which is up there at the very top, does show up after 20 seconds, because it shows up, here's 20 seconds, and the maximum happens after 20. It happens later. Like if I draw a line straight down, that happens after the 20 seconds. And I also just wanted to point out that this graph has no horizontal intercepts because it doesn't hit the graph anywhere at the horizontal axis. So that's going to be important on the real thing. I just want to make sure you remember what the horizontal intercepts are.